Hello, we are discussing about GATE 2000 ECE paper, and this question is related to analog circuits. Look at the diagram. We are going to design a circuit by using two ideal diodes and a resistor and two voltage sources that should convert the input voltage given in figure B to an output voltage, figure C it has shown. So this input waveform which is shown in figure B should convert into figure C as the output waveform that you are going to design. For that one you can go with two ideal diodes, one resistor and two voltage sources. Okay, this is a problem of two level clipper. That is, clipping action is taking place at two levels, at two references. One is at plus 5 volts, the other is at minus 5 volts. So how to design the circuit, now we will see. So the general block diagram of two level circuit is going to be looking like this one. There is a resistor which followed with diode 1 for example, and that is having a reference voltage VR1. Okay, and it is in parallel with one more diode, that is D2, in parallel with VR2 reference voltage. This is general block diagram of two level flipper. Output voltage is V0 and input voltage we are supplying it as V input. So this is a single resistor value R, and these are the two ideal diodes D1 and D2 with references VR1 and VR2. These are two voltage sources. So by looking at V input and V output, this is not okay, V input and V output, we can draw the characteristics, transfer characteristics like this. Transfer characteristics is characteristics between V input and V output. So this is Vi and it is V0, 0. This is 5 volts and it is 10 volts, and again it is minus 5. This is minus 10, 5, 10, minus 5, minus 10. So if you observe this one, for the positive half cycle, that is whenever V input is increasing from 0 to 10 and again coming back to 10 to 0, okay, 0 to 5 volts it is appearing and 5 to 10 it is not appearing. Okay, the voltage from 5 to 10 is clipping. What it is appearing is only 0 to 5. So it is going to be acting as a slicer. Okay, it is cutting above voltage and below negative peaks and positive peaks it is cutting, so that it is going to be acting as a slicer. Okay, two level clipper, and or it is also called as slicer. So till 5 volts it is appearing as it is. So output voltage is same as input voltage. Okay, and after, if V input is going greater than 5 volts, at that time output voltage is not following the inputs. Output voltage remains constant at 5 volts for the voltages greater than 5 volts. So the meaning is nothing but it is going to be constant at this voltage. And next, for negative half cycle also same thing. Output voltage follows input voltage till minus 5 volts it reaches. Till minus 5 volts it reaches. And after reaching minus 5 volts, okay, if V input goes above in magnitude, okay, minus 6, minus 7, minus 8, minus 9, minus 10 like this, at that time output voltage is going to be constant at minus 5 volts. So even though the input voltage changes between minus 5 to minus 10, output voltage is constant. So this is what transfer characteristics. We can say V0 is equal to 5 volts and V0 is equal to minus 5 volts. During this portion V0 is equal to V input. Okay, so now come for the positive half cycle, case 1. Okay, during positive half cycle, if input is greater than, okay, during positive half cycle, if input is V input is greater than 5 volts, then V0 should be equal to 5 volts. So the meaning of V0 is equal to 5 volts. Whenever V input greater than 5 is one diode is going to be forward biased, and that should be connected with a reference voltage as 5 volts. So we can think in this way, and the diode should be forward biased only when V input is greater than 5 volts. So this is going to be the case for N side. If you apply that 5 volts, VR1, which is nothing but plus 5 volts. We are applying reference voltage as plus 5 volts towards N side of the diode 1, and that is going to be connected towards input side. So if you are connecting in this way, this diode is going to be forward biased whenever input voltage is greater than 5 volts, and if input voltage is less than 5 volts, then the diode becomes reverse bias, because diode will be said to be in forward bias if P side is more positive than N side voltage. Already N side is connected with plus 5 volts. To keep this diode 1 in forward bias, you must apply more than 5 volts as input. So this condition gets satisfied. Whenever the diode gets forward bias, it acts as short circuit. Ideal diode acts as short circuit that makes zero voltage across it. So total output will be equal to 5 volts. So this condition satisfies if you are going to look at this and second case. And for this one, for the same positive half cycle, if V input is going to be less than 5 volts, then diode is reverse bias. Diode is reverse bias is nothing but it acts as open circuit. It acts as open circuit, so V0 will be equal to V input. In this case, V0 is equal to V input. Second case, from transfer characteristics we have shown that when V0 is equal to minus 5 volts when V input, magnitude of V input is greater than minus 5 volts. That is, V input is minus 5, minus 5.1, minus 6, minus 7, minus 8, minus 10, like this. For that one, output voltage has to struck at minus 5 volts. So for this one, output has to be struck at minus 5 volts. So we are going with a reference voltage as minus 5 volts. That minus 5 volts is reference, and it has to be equal to V0. So there must be a diode that should get forward bias. There must be a diode D2 that should be forward bias for the voltages of V input in magnitude greater than minus 5 volts. So if you apply V input in this way, at that time for the values of V input, which is going to be in magnitude, if it is greater than minus 5, minus 5.1, minus 6, minus 7, minus 8, like this, then this diode D2 is going to be getting forward bias, because for N side you are applying more negative voltage than P side. So overall effective voltage on P side is more positive. That makes D2 forward bias. So since D2 is going to be getting forward bias, so V0 will be equal to minus 5 volts. Else, if V input is going to be less than minus 5 volts and 0 volts, then by that time you are applying more positive voltage towards N side than P side. So diode D2 becomes reverse bias, acts as open circuit. When it acts as open circuit, at that time this is what the equivalent circuit. Even though you are applying minus 5 volts as reference voltage, but V0 is no more in connection with minus 5 volts, since there is an open circuit present. So this will not have any effect on the output. directly V input is going to be equal to V output even though there is a resistor present. Okay, so V naught is equal to, as there is no current flows through this resistor, since it is acting as open circuit, no voltage drops takes place across this R. Okay, so V naught is equal to V input effectively. So from this one we can say that for V input less than 5 and greater than -5, okay, both diodes are reverse bias. So V naught is equal to V input. For V input greater than 5 volts, okay, D1 forward bias and D2 reverse bias. Okay, so V naught is equal to struck at 5 volts. For V input less than 5 volts, then D1 reverse bias and D2 forward bias. That makes V naught is equal to -5 volts, which are nothing but from the transfer characteristics or from this diagram we can check. So the final diagram can be drawn in this way. Okay, so this is diode 1 with -5 volt plus 5 volts. Next, diode 2 with -5 volts. It is V naught and this side is V input R. So no need of knowing the value of R for this. Okay, so this will be D1 and it will be D2. This is VR1 and it is VR2. That's all. So if you are going to give a sinusoidal signal with 10 volts peak to peak, 10 volts peak, if you give as input for this circuit, at that time you will get the output voltage as shown. This output voltage you will get. Okay, thank you.